Using GPS, these trails represent pizza delivery in Manhattan on a typical Friday night. And is this a frog or a horse? It's episode 52 of IMG. This lemon looks yellow to me, and it probably looks yellow to you as well, but not in the same way. You see, here in this room, this lemon is subtractively yellow. It absorbs all visible wavelengths of light except for yellow light, which it reflects onto my retina. But the screen that you are using to watch this video doesn't produce yellow light at all. In fact, it can only produce red, blue, or green light. The really cool but kind of disturbing thing about this is that here in the room, I am actually seeing real yellow light, but you are seeing fake yellow. Absolutely no yellow is coming off of your screen and falling on your retina. But it still looks yellow because it's quite easy to lie to the brain. Our retinas contain 3 different types of cone cells that are receptive to color, and each one is best suited to detect a certain color. One is great for blue, the other is great for green, and the third is great for red. Notice that there's no individual cell looking for yellow. So the way we actually see yellow happens like this. The wavelength of yellow light falls between the wavelengths of red and green. And so when an object reflects yellow light onto your retina, both the green and the red cones are slightly activated, which your brain notices and says, well, that's what happens when something's yellow, so it must be yellow. All a computer monitor or a mobile phone screen has to do to make you think you're seeing yellow is send a little bit of red and a little bit of green light at you. As long as the pixels and the little subpixels on them are small enough that you can't distinguish them individually, your brain will just say, well, I'm receiving some red and some green. That's what yellow things do. It must be yellow. Even though it actually is not.